Okay, another formula we're going to be working on today. You see we have two cylinders now, and we're going to see what happens when we push down on this cylinder and how much weight we can hold on that cylinder. This would be like a forklift or something to see how much pressure the pump's putting in compared to what it can lift. So we're going to say we have, let's go ahead and say 100 pounds of force pressing down on this cylinder. And let's say this cylinder is 2.5 inches round for area. Now, on this one, we're going to figure out how much force we have, or how much pressure we have in the system. So let me get my assistant. And to figure this, we have to go back to our formula. Now, again, we got to use this formula all the time. It's going to help you if you just write it down and you take out what you need until you get used to what to do. So we know we have force, we have area, we do not have pressure yet. So we'll take out our pressure. So how do we figure the pressure? Well, force divided by area. So when you go up and down, you divide. So always remember, that's the dividing line. It has to be divided. Side to side, we multiply. So we take 100 divided by 2.5, and that gives us 40 pounds of pressure in that system. Let me write that with a different color so we can see it a little better. So we have 40 pounds of pressure in that system. And again, with hydraulics, the fluid travels undiminished. Again, the hose slows us down, but it does not change our pressure once we get the system equalized. So, how much weight can this system hold with 100 pounds of force and 40 pounds of pressure inside the system? So again, we got to look at something. How much area does that cylinder over there, how big is it? So we're going to say this one is, let's go 8.5. Let's put that point in there so you can see it a little better. So 8.5. So 8.5 inches round, and we have 40 pounds of pressure. That means we don't know our force over there yet, or our weight they're going to be pressing with. So we know our area now, and we also know our pressure. So side to side, we multiply. So again, 8.5, which is our area, times 40 pounds of pressure. Again, it don't matter if I go 40 times 8.5 or 8.5 times 40. Multiplication, it doesn't matter because it always equals the same. And that equals 340. As long as there's no more than 340 pounds of pressure or force on that side, 100 pounds can hold that. Now if that's 380, of course it's going to start dropping and start forcing back against this 100 pounds. And making this 100 pounds have to change. So that's how you would figure that one. Now, what happens if we don't know our area? Just to make sure we cover every single aspect of this. So we don't know our area. So we'll say we have 75 pounds of force, and we have, say, 33 pounds of pressure. Let's make it kind of weird. So, how are we going to figure that? The same way we figure with the area, because now we don't know the area, so we're going to take it away. We know our force, so we're going to add that back in. Force is always divided by whatever's below it. So, 75 divided by 33 pounds of pressure equals 2.27. So we got a 2.27 inch cylinder. So to keep this equal, we'd have to know some variables on this side. So we got 33 pounds of pressure. The board's about to fall. And let's say we're picking up 50 pounds. So to tell if we can hold that 50 pounds, which you'd think we'd be able to, but let's just say sailor cylinder is 18 inches. So let's see if an 18-inch cylinder at 33 pounds can hold that. Well, actually we're trying to find area. So how big would that cylinder have to be? Sorry about that. How big would that cylinder have to be to hold up that 50 pounds with all this? So we would take our 50 pounds of force. Again, we know our force, 50 pounds. We know our pressure, 33 pounds. So you take 50 divided by 33 equals, it has to be 1.5 inches to be able to hold that up, at least. Because if it was less, again, it would change everything. If it was, say, an inch, you would only be able to hold up 33 pounds. So again, you always need two variables, but that's how you figure this. Now, just to keep everything going here, we're going to do at least 3 different ways, just so you'll have it all. So we're going to say we don't know our force here. So we don't know our force there. Let's say we have 150 pounds of pressure in the system. We have a 7-inch cylinder, 12-inch cylinder. Now pretty much, to be able to figure this one, you want to figure out how much force each cylinder can handle. So we don't know our force. Let's take that out. We're going to put our area back in because we know our pressure, we know our areas, but we don't know our force. So we're going to say on this first one here, 150 times 7, we can handle 1,050 pounds of force here. To keep that's how much pressure that can handle right there. So the other one, 150 times 12, 1,800. Now that is how the system stays equalized. So a cylinder at 12 inches can, with 150 pounds of pressure, can hold up 1,800 pounds with the pressing force of 1,050. So that's how you would work that one. Again, like always, if you have any questions about these or need a little extra support or help, please contact me. My contact information is on your main screen. But please work these, draw these out. Again, you'll need them on the quiz. So make sure the formula is wrote down. Make sure you use it. And I recommend erasing one or covering one as you work your formula until you get used to which one goes, how you work it. how you know that force is divided by or area is times by. So if you have any questions, please contact me. Thank you.